Okay, my friends, take a little time, slow down. What do you think you see here? What are you looking at? Is that natural? Does that look normal to you? What do you think you are looking at? Look at this feathery looking thing. It almost looks like a leaf. But they're all over these things. It's not just there. They're everywhere. And all of these little leafy looking patterns hanging all over these tubular looking things. What is that all about? Well, I know what it's all about. This is a digestive system. I'm not kidding you. And you're going to make fun of me after I tell you where it is. It's up in Alaska, and it feeds Mount Spur. These are the guts. That's a creature's guts. And all of that guts worked its way over here to Mount Spur. And guess what Mount Spur is? It's a rectum. I'm not kidding you. It's a rectum. And you see this here? You see this feed off of here? Why is that this color? Why is it green like that? And why is this one like real darker green? When you get into the end of the digestive system where you are pooping and all that stuff, you end up with all these different effluents, they call them. All right, that's not just glacier. That's something coming out of there. The same thing over here. You see the color here? Why is that color like that? This is literally body fluids flowing out, and Mount Spur is the actual anus and rectum. And the funny thing is, this is hilarious, because I lived over here on the other side of Cook Inlet for a couple of years when I was in the Army service in Nike Hercules missiles. And I didn't even know Mount Spur was there. So here I am doing my research, I don't know, 15 years or so ago. And I wanted to know what is in these volcanoes, because I had, once I realized the Earth was alive, I said, well, where are volcanoes coming from? Why is that? Well, it's just like you take biological material and you cover it up. It will boil and burn. It'll that's what they call spontaneous combustion. You take biology and you cover it up and it cooks if there's no way for that heat to come out, because that's a biological breakdown. Well, the same thing's happening under the ground. And when they get to the end and they have to poop, that's what. And there was a plane, I was watching a video showing where they were actually flying over the top of Mount Spur, right over the peak of the volcano. And it went, boop, it just farted when they went over the top, and I mean, it was a fart. And you could see the boom, you could see the actual, almost like a nuclear wave coming out. But this is all biology. Isn't that something? Now, I get another one for you you're going to have a hard time understanding or believing, was that the source of the Nile. What's the source of the Nile? Nobody's ever been able to figure it out, I don't think. You see this? The source of the Nile River, a mystery spanned 3,000 years, 3 millennia. Seemingly simple question of geography captivated explorers and rulers throughout history. Nobody could figure this out. The quest to discover the source of the Nile was one of the most important scientific questions of the 19th century. Well, it's difficult to envision such a conundrum in the era of Google Maps, because now we can obviously see where it came from. The search was nearly as gripping as the race to put a man on the moon, as it was wrapped up in heroics and intrigue. Expeditions led by glorification of figures like David Livingstone, Henry Stanley, they all wanted to figure out where it came from. They still couldn't figure it out. So now they think, oh yeah, we got it all figured out now because we can look on Google Maps and see where it came from. Well, where is the source of the Nile? They're going to say well, here, I'll show you what they say. Hold on. Okay, here's how they explain it. They say the Nile has two major contributaries, the White Nile and the Blue Nile. Well, where do they get their waters to contribute? So let's go look at that. All right, here's why they could never figure out where the Nile River got its water from, because there's nothing coming out of here. They say, oh, this is the White Nile and the Blue Nile and all this, and it turns into the Nile River. All of a sudden you got a ton of water. Where did it come from? I know exactly where it came from. It didn't come out of here. It didn't come out of here. It came right out of here. And you say, well, where did it come out of there from? It came out of there because that is biology, my friend. That is an absorptive area of biology. You see this? That's not just accidental. And these things right here are not actually accidental either. They are nothing more than vascular type of network to pull water in. You see that? That's pulling water in to this Nile region here, all the way down. This is the same stuff. You see that? Just take your time and look at it. Think about, why would it do this? Why would that happen? Look at them. They connect right in. All of that can absorb whatever it can absorb. It's trying to pull water out of whatever this is. I'm telling you, the Earth was one time was alive, and I don't know if it's alive anymore. I really don't. But it sure as hell didn't come out of here. Look, there's nothing here. Where do they think the water came from? There's virtually nothing there. This is still biological tissue down here. But by the time you hit where it's really starting to absorb, and now it's starting to get absorptive tissues are working, you see them? And they're getting bigger and bigger, and they're getting more absorptive. This is the source of the Nile right here. Absorption of wherever it's coming from. And then it just keeps getting bigger and bigger. And then you look at down here, well, you know, look at it. And then this whole area fills in, and then it has to go somewhere. And it keeps absorbing moisture. It's just like in your colon, when just before you poop, all that moisture that's in that poop gets absorbed back out. Now in this case, it's going the other way. The moisture's going in. You see that? And then it just keeps on running. And people are using that water to live, and it's just a source of life. It's the life-giving source of this whole area. Now, I don't know whether it's still absorbing out here or not. It doesn't look like it. It looks like they're just living on the edges of it. But everything is so fragile. We got to take a whole new approach to what we're doing here on this planet. We really, really do. And that's the outflow. Usually when you see these kind of colored pools and lakes, and they're going to be all kind of different colors, and that's chemistry that is working with the digestive system. I mean, these are all digestive systems. And when you get to your colon and to your rectum and all that area, there's still a lot of biology going on. Like this might be absorbing sulfurs or something. You just don't know. You just don't know. But the colors indicate different chemistry, and you can actually see this, whatever it is, I don't know. But it's some kind of different type of chemistry in this area. This, I don't know what the hell's going on here. That looks almost like a blood vessel or something. But when you see these different abrupt breaks in the colors, that means you have some kind of different tissue variation going on. Because once you get right down to the bottom layer of everything, it's all some kind of tissue. You could spend hours on Google Map, or Google Earth looking at this stuff. Fascinating, isn't it? You think that's just accidental? This is biology. Pretty incredible. Okay, another shocker for you. Yellowstone, that whole area, everything, it's all biology. And they just came out with hidden channels beneath Yellowstone have been revealed for the first time. This is the digestive system. Listen to this. This is where the Yellowstone farts. It says the work reported in this study could even be used to get advanced warnings of volcanic hazards. All right? Well, why would a volcano happen? It occurs when the clay layers underneath Yellowstone get temporarily sealed off. The clay layers are tissue, body tissue, and they sort of pinch off. They get sealed off, leading to a dangerous fart. I mean, a dangerous and potentially explosive buildup of fart gases. I mean, of gases. And then they explode. Where do you see Mount Spur? This is hilarious. The whole thing about Mount Spur was just ridiculous. I lived right across the street from it, and I didn't even know it was there. All right, so here's Mount Spur. In 53 it went off, 92 it went off, and then this is the one I was watching a while back. This is active volcano in Alaska, Mount Spur. I think this is the one. Let me get into it and let's see. You see, that does literally poop from Mount Spur. You see these colors? You see immediately the green stuff starts growing in it.
Proximity to Anchorage, no one lived in its destructive path. The volcano I'm referring to is Mount Spur, which produced another large eruption in 1992. This video will discuss...
Look at this. You see these colors? You see this? Anybody that knows mud fossils knows what that is. This is biology, and this is because it's a suppression of biological poop, basically, from a digestive system, and the thing finally just farts and takes a crap. That's basically what it is. When volcanism comes out and all that stuff comes out, that's nothing more than poop. All right, let's see what else they got to say.
Discuss this volcano and mention what its future hazards are. Mount Spur can be found in south-central Alaska, where it is 80 miles west of Anchorage. Mount Spur began forming 255,000 years ago. All right, they're just guessing at all the rest of that stuff. I was in Anchorage. I didn't even know Mount Spur was there. I lived right over the other side of Cook Inlet. You see these different colors? Whenever you see those different colors, and I showed you, I believe, all of the guts and everything of Mount Spur and all of the chemistry that pulls back in the moisture and so forth from all of those, I think they were intestines or something like that. And they talk about in this video, you can watch the whole thing if you want, but they talk about finding different, there's like a crater volcano or something opened up a few years back, and it's not far from Mount Spur, and they believe it's part of the same poop system, basically, and it has a lot of different chemistry, just like your digestive system is. Your small intestine has a lot of saltiness to it because it's coming out of an acid from the stomach.
So there's two different chemistries there. One of them, when you look at the lakes and stuff, sometimes very, very blue is one type of chemistry, green is another, yellow will be another one, white looking stuff is another one, and there are different types of chemistry in the body. Bile has its own certain color. They all have their own color. Just like I showed you in the transition metals, or you take a look at them, transition metals are all different colors. Alright, the reason I'm always talking about these transition metals is because they are linked to the movement of bodily products within your body juices, primarily in your blood. And you see all these +2s and 3s and all that business. That means these particular metals can pinch other molecules, carry them down, drop them off, pinch something else, bring it back up to the lungs and the heart and the kidneys and the liver and all that to clean the blood. They are the transporters, and they are, in what it says here, these colors can vary depending upon the charge. So when I'm going to grab something with a certain charge, when I'm going to have a bigger charge, when I have a bigger charge, a smaller charge, so forth. So it's going to vary what it will grab depending upon the charge of the particles. Now, these groups are called ligands. These are pinchers. I call them pinchers. And they attach to the metal ion, which is the metal in the center, will grab a hold of these, and they call them aqueous solutions. That means they're in the water, and the ions, which are these different plus and so forth charges, form complexes, very complex, and then the colors show with all these different colors. So when you see biology that has all these different colors, the colors are in the blood. They're in the transition metals, primarily in the blood. All right? And blood is everywhere in your body. So sometimes it pools in the kidneys and the heart and the lungs, and I have examples everywhere. Every single one of those things. And all these different colors everywhere. You see this? Wherever there's blood, there's transition metals. Wherever there's transition metals, there's colors. You see these blue, green, and all these different colors? That's a gigantic lung from a gigantic creature. And that lung, when it was, it's just like this. It's just like this. It's laying there on the ground. And these get dried out, and they can walk on these. As a matter of fact, there is people walking on. I might have already showed you this, but what's this? There they are right there. You see it? They're walking around on that lung. And here's just sort of a wide shot of it. And it changes colors depending on how much water's in it and the time of the year and so forth. You see that? That's also up on Mount Spur. In that area, somewhere up in that region. This is not normal. That's just not average, like runoff and all that. These different colors and everything. You see, I talked about the colors and so forth. This is some kind of vascular network, or I don't know exactly what it is, to be honest with you, but it's certainly not just average landscape.